Good morning, everybody, and welcome to our pre-calculus 40th class. Yesterday, we started this chapter 6, part 2. We are now doing the graphing of trig function. We're going to focus on sine and cosine. So we talked about that yesterday. So what we're going to be doing is we're going to talk about specifically a transformation. So we can look at it in a transformation view. And then when we look at that, we can also think about how those kind of transformation will change the characteristics of our trig function graphs. So the very first thing that we talked about, I'll read this off first. The general form of a sinusoidal function is y equals a sine b times x minus c plus d. So the parameters a, b, c, and d, right here, a, b, c, and d, are the transformation. It changes the size and shape of our graph. We've seen that before. So when we look at the transformation form before, we say y is equals to a f of b times x minus c plus d. So a, last time we said this a tells us that this is going to be a vertical stretch and a vertical compression. And it will also talk about the vertical reflection. Okay, so that's when we talk about transformation. This a value changes the stretching or compression vertically and the reflection vertically. The b tells us the either horizontal compression, compressing it horizontally, or stretching it horizontally, as well as the reflection horizontally, which is reflecting over the y-axis. C talks about, when we talked about this, C talks about the horizontal shift. Okay, if C is positive, it will shift to the right. And if C is negative, it will be shifting to the left. And this is going to be always minus. So it's X minus C. So, okay, so this is not the negative C, it's minus C. So the C is a standalone number. Plus D, the D, when we talked about transformation, we said D is a vertical shifting. If D is positive, you see this is a plus. If D is a positive, it will be up. And if D is negative, it will be the graph will be shifted down. So how do those things affect our sine function or function graph? It's just so convenient that the A is the amplitude and A is the parameter A here. So it's just kind of nice that A is amplitude, but also A is the vertical stretch. So the A value in our sinusoidal equation controls the vertical stretch. If A value is anything other than 1, the A value will appear as a coefficient of the sine function or cosine function. If the A is negative, the graph is also reflected into the x-axis. So there's a vertical reflection right there. So what does the A in here? A represents the amplitude of the sinusoidal graph. Okay, now what does the amplitude mean again? So when we looked at that one, the word amplitude yesterday, we said amplitude is a distance between the middle line to the maximum, is a distance from midline to maximum or minimum, because that's the same distance. So amplitude talks about here to here. Okay, if this is a middle line from middle line to the maximum, how far are they? Or from a middle line to the minimum, how far is it? So the A value will also determine the amplitude. So amplitude, we've already seen this formula, and I gave this formula yesterday. So amplitude is equals to maximum value minus minimum value divided by 2. You see that there is an absolute value there because the amplitude just talks about the distance or how far apart. So where amplitude is going to be a positive value, even though the A is negative over here. We'll see that right away. So study the graphs of y equals to 3 sine of x and y equals to negative 2 sine of x and y is equals to 0.5 sine of x. Then complete the following table. So the very first thing that let's take a look at this one here. Y is equals to 3 sine of x. So 3 sine of x, I think there's a mistake in here. There has to be a 3 there. Okay, so make sure we put a 3 right there. So this is y equals to 3 sine of x, right? This one over here, because it's a sine function, okay, the 3 is the amplitude. So as you can see, the original sine function goes up to 1 only. Okay, so the original function only goes up to highest 1, to negative 1 is the lowest, and so on. So the amplitude here, the distance from middle line, this is our middle line, to the maximum is 3. So the amplitude is 3. And that is that value right there. Amplitude is equals to 3. Domain. Now in this particular case, the graph starts here at 0 and then the values for x keeps going. So in this particular case, it's going to be from 0 to infinity, including 0 to infinity. They didn't say any specific domain for this one. Okay, and then the range is going to be the possible y value. So this graph here, if we follow this one right there, the minimum is negative 3, the maximum is positive 3. So the range is from negative 3 to positive 3. So we can just write our domain and range as an interval notation. If you also want, you could write that down as a set notation, but we'll leave it like that. Okay. So now let's take a look at the negative 2 sine of x. So negative 2 sine of x, two things that are going on in here. Sine of x this is what the sine of x looks like, just to kind of refresh our memory. It starts at 0 to 2 pi. This is pi. This is 1. This is negative 1. So the graph looks like this. Okay. So, but in this particular case, it starts off at 0 and then it goes up. But for y equals to negative 2 sine of x, this negative here in the a value makes the reflection into the x-axis. It's a vertical reflection. It got flipped over. Okay, so this one here talks about the reflection, a vertical reflection over or into the x-axis. And then the 2 tells you it's a vertically stretched. So that means it's a vertical stretch by a factor of 2. So that makes the amplitude get a little bit bigger. Okay, so it's reflected into the x-axis, so it's a vertical reflection, and it's also stretched. So what does that mean? What's the amplitude? So amplitude is the distance from middle line to the maximum. So amplitude is equals to 2. Even though it says -2, the amplitude is 2 because it's going to be always positive. And just to kind of refresh your memory here, the absolute value talks about just the positive value. So amplitude is 2. The domain, so this is the one that we're looking at right here. So the domain starts from 0 and it goes on, right? Because there's an arrow all the way, so to the infinity. Okay, so square bracket says 0 to the infinity. And then what happened to the range? What's happened to the range? The lowest it can go is -2. The highest it can go is +2. So the domain is from -2 to +2. Minimum y value, maximum y value. Okay, so let's take a look at this one. I'm actually gonna go back to this one. I'll write a little bit of note here. So vertical stretch by factor of 3. And there has to be a 3 there. I don't know why it's gone. Okay. So let's take a look at the last one. Y is equals to 0.5 sine of x. So the A value is 0.5. So that means this is going to be a vertical compression by a factor of 1/2 or 0.5 in this case, right? 0.5 and 1/2. No reflection going on in there. So that means whatever the original function is, this is the original y equals to sine of x. It's compressed by a factor of 1/2 vertically. So the amplitude now, the amplitude is the distance from middle line. So this is our middle line to our maximum. That's now 1/2. So amplitude is 1/2 or 0.5. The domain, so we're going to follow this smooth curve down here. It's smaller amplitude. The domain is from 0 to infinity because it goes on. And then the range are the possible y value. So the lowest it can go is a -0.5, and then the highest it can go is +0.5. So the domain is -0.5, comma, +0.5. Okay, so that's the first transformation that we're going to see. So the vertical stretch, the A value in our transformation right here will tell us the amplitude of the sinusoidal function of the sine or cosine graph. Okay, so I'll just write that down. So A value will give us the amplitude. Oh, it's okay. I have it all over here. Now let's take a look at the next one. Okay. The next one is the b value. So I'm just going to write the function here. Y is equals to a sine of b times x minus c plus d. Now we're going to look at this parameter b. What does that do? According to our transformation, when we learned the transformation before, we said the b will tell us the horizontal compression or stretching. So b is going to be horizontal compression or stretching, but by the factor of, okay, so b is horizontal stretch or compression, doesn't matter, depends on what the b is, by a factor of 1 over b. So let's see now. Let's see if we can connect the stuff together with periodic function. So a function that repeats its value in irregular intervals over the domain is called a periodic function. We know that yesterday. The graphs of y equals the sine of x and y equals to the cos of x are both periodic functions. We know that from yesterday. Period is the horizontal length of one interval or one cycle on a periodic graph. So a period tells us basically how long for one complete revolution, one complete cycle. So from the general equation of a sinusoidal function, y equals to a sine b times x minus c plus d, the parameter b represents the frequency of the cycle within the interval of 2 pi. Therefore, b affects the periodicity of the cycle within the interval. So therefore, b affects the period. Now, how can we figure that out? So the period of the graph, how long will it take to make one complete cycle, is equals to 2 pi over b. Okay, but we are using pi radians here. They wrote down this part over there. Okay, there will be also times when we're going to be finding the b. So if we know that period is equals to 2 pi over b, then we can also say that therefore b is equals to 2 pi over the period. We're going to see this later on when we talk about word problems. So that's why I wrote it down. Okay, so if you solve for b, it would be b equals to 2 pi over the period. Okay, so let's see here. Before we get into that one, I just wanted to say something. So y is equals to sine of x. So here, it means that there's 1 here. b is equals to 1. Okay, so that means in 2 pi radians from between the span of 2 pi, we're going to have one full wave in a span of 2 pi. Okay. Now when we get to y equals the sine of 2x, so they're saying here the b is equals to 2. It means that we have to fit two complete cycle in the span of 2 pi. So how can we make, if this is 0 to 2 pi, How can we have two of these? Well, the only reason we can have two complete cycle, two complete wave is when we squish them like that. Okay, so this too tells us that there's going to be in the span of 2 pi, there's going to be two complete waves. Okay, so that's what that means. 2 pi, you're going to only have half a complete wave in the span of 2 pi. So in that case, we have to stretch it. We'll see it in a few minutes. Okay, so let's study the graph of sine equals to 4x. What's happening in here, the b is 4. The b is 4. It means that we need to fit 4 complete wave in a span of 2 pi. So what does that mean? What's the period then? So let's take a look. This is for which one is which? This one over here, the dash, that's the one that says sine equals to 4x. So this here is y equals to sine of 4x. So let's watch this. So from here to here, that's 2 pi. The 4 tells you how many complete wave can you fit in 2 pi. See, there's 1, that's 1 complete wave, 2 complete wave, 3 complete wave, 4 complete wave. So how can we fit 4 complete waves in the span of 2 pi? The only way we can do that is if we can squish them together. We can compress them together. So what does that look like? So the A is still 1 in this particular case. Okay, so let's answer these questions over here. What's the amplitude? So amplitude is A equals to 1. What's the domain? So we're going to focus on the dash graph here. The domain is from 0 to infinity. 0 to infinity because it goes on continually. Range is the possible y value. So we know that this graph here goes down to -1. The minimum is -1. The maximum is 1. So the range is going to be from -1 to +1. Okay. Now here goes the period. We know that the b value is going to be 4. So period, I'm just going to write this down in here. P is equals to 2 pi over b, okay, which is 2 pi over 4. Let's simplify that. That's going to be pi over half. Pi over half. So what does that mean? That means, okay, how long will it take for one complete cycle? How long will it take to complete one cycle? Where's pi half in our picture? So where's our pi halves in our picture? So we go from, this is pi, from 0 to pi is there. Pi half is there. Pi half is here. Okay. So it's saying that, now as you can see, this is one complete cycle, one complete wave. And how long did that take? From 0 to pi halves. Okay, so that's what the period is. they tell you, the period tells you how long does it take for it to get from here to make a complete cycle there. Pi halves. Okay. I wish you can ask questions, but if you have any questions, you can email me. Now let's take a look at this one. Y equals to the sine of 0.5x. Okay, so which one is that one? This is that graph here, the solid one. The solid one. Okay, the solid graph is our sine equals to the 1/2 x. And over here, they just wrote down 0.5. That's okay, they're the same thing. The a value is not written here, so it's understood it's 1. The b value is 1/2. So let's take a look. So amplitude is still 1. The domain are the possible x values. So that's going to be from 0 to infinity. The range, we're following this solid graph here. The lowest is -1. The highest is +1. So the range is from -1 to +1. Next thing that we're going to do is period. Okay, period. What is a period? Period is equal to 2 pi over b. And what's the b? It's a half. So 2 pi over 0.5, which is equals to 2 divided by 0.5 is 4. So 4 pi. So what does that mean? It means that for one complete cycle, one complete wave, it's going to take 4 pi. So let's take a look. So this is one complete wave. It's going to take 4 pi to get to that. Okay. Now this 1/2 here tells us that you're only going to get a half a wave. We're only going to get a half a wave if we go for 2 pi. Okay, so if we go up to 2 pi, we're only getting half the wave, just this half, not the complete wave. So if the period talks about how long would it take for one complete wave. Okay, so that's the b value. The b value, when we think about our transformation, it's a horizontally compressing and stretching. So here, this one over here, I'm going to write that down in a transformational wording. So here, b is equals to 1/2. B is equals to 1/2. That means it's horizontal stretch by a factor of 1 over 1/2. Okay, what's 1 over 1/2? That's equal to 2. So horizontal stretch by a factor of 1 over 1/2, which is equals to 2. So horizontal stretch by a factor of 2. So it got stretched. Now this one here, what does that mean? So B is equals to 4. So that means it's a horizontal compression by a factor of 1 over B, which is 1/4. So everything is multiplied by a 4th. Okay. So that's a transformation wording. Okay, good. Now let's take a look at phase shift. Now, what does a phase shift mean? It's a different wording, but it's basically a horizontal translation. If we think about and connect to our transformation stuff, it talks about horizontal translation. So for the general equation of the sinusoidal function, okay, again, it's written in here. I don't have to rewrite it. A talks about the amplitude. B talks about the period. C is the horizontal shifting. It's called phase shift. So C controls the phase horizontal shift. In general, the graph of y equals to sine x minus c is the image after sine of x has been translated horizontally. So a phase shift is figuring out where does the sine function normally starts. And then it's shifted this much horizontally. So if C is positive, then we're going to have horizontal shifting to the right. If C is negative, then it's going to be horizontal shifting to the left. So now we have two things in here. Study the graphs of y equals sine of x. Okay, so y equals the sine of x is this part right here. That's the dash. That's the dashed one. Okay, so sine of x. What does the sine of x look like? You're gonna always think about that. So sine of x looks like this. Starts with 0 to 2 pi, and then in the middle is also 0, maximum, minimum. That's what the sine of x. These are the key points we talked about yesterday. So 0, pi, 2 pi, those are the zeros here. And then this is going to be pi halves. At pi halves, it's 1. At 3 pi halves, it's negative 1. Okay, so that's what the graph looks like. So that's this one right here. Okay, so these are the key points. 0, pi, 2 pi. So those are the zeros. And then at pi halves, this is pi halves. This is 3 pi halves. At pi halves is 1. 3 pi halves is negative 1. That's that one. Okay. And, okay, so study the graphs of sine of x, which we've seen here, the dash. Y equals to the sine of x minus pi halves. Well, what does that mean? That means we're taking the sine of x function graph, and then we're translating pi halves to the right. Pi halves to the right, right? Because this is going to be x minus pi half, where the c is going to be the pi halves. Translating. So every point in here, this point here, got translated over their pi halves right there. Okay. This point right here got translated pi halves right there. This point right here got translated pi halves right there. This point right here got translated pi halves right there. And then this point right there got translated. So every single point got translated to pi halves. So let's see what it would look like. So value of c in this case, c is going to be 0. So y equals to sine of x. There's no c value, so c is equals to 0. So if you want, we can go like this, x minus 0. So there's description of phase shift, no phase shift. So we don't shift it to the left and we don't shift it to the right. Okay. Now what about this one here? The one that we have on the graph up here. So the C is going to be pi halves. Okay. So that means we're shifting the graph, shift to the right by pi halves. Okay, so shifting to the right by pi halves. Okay. Now this one in here, for the rest of these ones in here, they gave us a whole bunch of examples here that's not graphed up above. So what we're going to do is we're just going to figure out the C value and describe the shift. So sine of x plus pi over 4. Remember, this is going to be, this is supposed to be x minus something, but this is plus. The reason why it's plus is because it's the pi over 4 is a negative, so it's going to be x minus negative pi over 4. So that means, so C is equals to negative pi over 4, and I'm sure you remember that from our transformation. And what does that mean? It's going to be shifting to the left by pi over 4. Okay, so the negative tells us it's a shift to the left. By how much are we shifting to the left? Pi over 4. And let's take a look at this one. Okay, well, cosine is interesting. Okay, so still the same periodic function, but in this case, x minus pi over 6. So the C value, the phase shift is positive pi over 6. So that means we're going to shift, okay, because this is a positive, we're going to shift to the right by how much? Pi by 6. And then last but not the least, cos of x plus pi. Well, the reason why this is a plus is because it's cos of x minus negative pi. Okay, so that becomes C is equal to negative pi. That means that we're going to shift. Okay, negative means to the left by how much? By pi. Okay. Okay, so what have we done so far? We've done A, the parameter A. So just to kind of review this, we've done the parameter A, which is the amplitude. That's a vertical stretch or compression by a factor of A. B tells us the horizontal compression or stretching, and maybe and reflection too. And that also affects the period of our graph. We talked about the C value, that's the phase shift or horizontal translation. Now we're going to take a look at the parameter D. So we know that the D controls a vertical shift. Now if D is positive, the graph is shifted upwards. If D is negative, the graph is shifted down. Okay, so that's basically all of that stuff. So we finished it. There are some assignment questions in here that we can work on. Okay, so, I posted it on the blog, and I don't know if you've been keeping up with the blog, but June the 12th is our last day of classes, meaning we have to get pretty much everything done by June 12th. So make sure, and I posted that because I want everybody to to see that there's the end of our classes. We're not doing, up to June 12th. That's basically the end of it. And then we will compile of our marks. So it's also a good idea to show that, to let you know that, like when you know where the finish line is, we tend to not give up, right? We tend to say, oh yeah, well, I only have this many weeks left and I gotta keep going. So this particular unit, I also said that it's going to be a very short unit. It's going to take about a week to finish, and then we are going to move on to other chapters. So let's keep up with these work. So page 521. So some of these questions are basically characteristics of the function. So it's something that we've already done. So this one here, identify the amplitude, the period for these, the phase shift. Oh, 3, 4, 5. Okay. The phase shift and so on. For question number 4, for each of the following, cos of x. Okay, we've already seen this cos of x. You can graph it here and then figure out the characteristics. We're gonna not do letter C because we haven't done tan of x yet. So that's not the one. Okay, so we're gonna go to question number 3, question number 4, except for now, omit question number 4C because we haven't quite done the tangent yet. For this one, number 5, number 6, number 5, number 7. Let's do number 7. Okay, so cos of x plus 1. So sketch the graph of that one. Describe your strategy. So in this particular case, what we could do is you can start with the cos of x. What does a cos of x looks like? What's a normal cos look like? And then it's a translation 1 unit up. So once graph the cos of x, and then once you have the graph of cos of x, everything is translated up 1 unit. Okay. And number 7, number 9, and multiple choice 1. Okay, so some of these questions we will do. 5:30. Yeah. Okay, so try some of these questions, and if you have any questions, we can talk about it. Just email me, and then I could go through some of these questions during our live stream. Okay, so any questions, send your question to me through email, and then we'll go through this. One final thing that I want to mention, because we are going to be talking about a lot of graphing, I've printed a whole bunch of graph papers. Now, they are sitting at the school, and if you need graph paper, you could get them. You could buy it yourself, of course, if that's something that you're interested in. But if you would like to grab some graph paper from the school, just call the school first and pick some up. Okay, you grab 50 graph papers. That should be a lot. 50 or 60 graph paper, that should be enough for per person. Okay, so grab some. They're there. It's for you that I've already set up. Okay, so give these questions a try. I'll probably go over some of these questions tomorrow, and then we'll go on from there. Okay, have a great time practicing these questions that we've done, and then we'll continue on with this tomorrow. Okay, have a great day, everybody, and I'll talk to you either later or I'll talk to you tomorrow. Okay, bye for now.